Done, ma'am.
Okay, everybody has finished? Okay, so that's it for today. We'll meet in the next class and we'll continue. Bye-bye.
Thank you, ma'am.
Yeah, good evening, Yuvita. Am I audible?
Yes, sir.
Okay, let's quickly start with the questions. So in the last class, we have gone through questions related to Werner theory, IUPAC nomenclature, okay, types of salts, right, and spectrochemical series, which were asked in NEET. Okay, so let's do some more questions related to bonding, electronic configuration, magnetic moment of these complexes, right? In case of any problem, do stop me, do ask me, okay, and we will discuss it in detail, right? Which chapter is going on in the school, Yogita? Because schools may have started. So mostly this is a very important chapter, and you see a lot of questions coming from this topic. So let me start with the questions. Okay. These are all NEET questions, some previous year questions. So which of the following complex is going to show maximum ionic conductivity? So how we are going to do this problem? Maximum conductivity because of the ions. So how you are attempting it? In case if you need my help, okay, related to the concepts and all, you can clearly ask me, okay. So basically, when you put them in water, they will split into ions, right? And they will start conducting electricity. That's what the question it says. So Jovita, which is going to, this is from the NEET PYQ. And you can tell me which complex is going to show the maximum electrical conductivity. So first of all, what is going we are going to do is we are going to write the complex one by one, and we are going to split them into ions. Got it? So this is going to get splitted, has 4 potassium ions.
Sir,
Yeah,
option A. 5.
exact. Yes. How many ions are there? Very good. Option A is the correct. Yeah, 5 ions are there. And just you can tell me which complex, though it is not asked, it can be asked in any question in the upcoming NEET. Which complex is having least electrical conductivity?
Option D.
Option D, because it doesn't split into ions. Okay, everything is within the square bracket. Got it? Next
Yes.
question. So, what is the coordination number and the oxidation state of bromine? In K3, Cr C2O4 whole threads. You can also try to get the IUPAC in of the complex. So we are going to start with potassium. I hope you may be doing in that way only. So you have potassium.
Yes.
Potassium is always plus 1. Okay. So this is 3 potassium ions that you know already. And the charge on the square bracket is going to be the opposite of the total positive charge. So it is going to be chromium. It can be written in short form like this. Many places it is written like this. Okay, so be careful about it. 3 minus. What is the oxidation state of, what is the charge on oxalator? And what is the denticity of oxalator? That we can discuss.
So option D. C.
Options C, yes, exactly. The coordination number is 6 because oxalator is a bidentate. Whenever it is bound to the metal ion, it donates 2 of the lone pair, 2 of its lone pairs. And there are 3 oxalator ion, as you can see. So total 6 coordinate covalent bonds will be there. So the coordination number is going to be 6. The oxidation state you can very easily calculate. The charge is -2, okay, into 3 equal to the sum of the total algebraic sum of the total charge is equal to the net charge, that is -3. So x equal to +3. So this is the correct option, right? Next is what is the density of the density of these ions respectively will be of these ligands. So EDTA is a very famous complex. Ethylene diamine tetraacetate we have seen just at the starting of this NEET questions.
Say
Option
B.
B or D? Second option or the third option?
B.
Second one, 2, that is 6. Acetate is 1. Yes. Ethylene diamine is 2. And what is the full form of diene? Diene is diethylene triamine. Got it? It is like this. Ethylene diamine was like this. This is diethylene. Diethylene means you have the 2 ethylene parts, right? Is it clear?
Yes, sir.
So it is a tridentate because you have 3 nitrogen. EN is bi or didentate. Di-EN is tridentate. In case of EN, whatever the number is written, just add 1 to it. That will be the density. Got it? So it is a tridentate. EDTA we have seen already. Acetate was monodentate. Ethylene diamine was having 2 NH2. So this is going to be the right answer. Got it? Is it clear?
Yes, sir.
Okay. Next is FeCO5. This is the question from NEET 2018. Is an example of dinuclear complex. Dinuclear complex. So basically, they are trying to ask what that some number and nuclear complex means. Nuclear actually it is a the term is itself is unclear. Okay, so don't get confused by the actual meaning. Just try to figure out roughly what it can be. Okay, actual meaning is not what means it will not match with the formula, right? So you need to know what that polynuclear complex means, what that dinuclear complex means, what that trinuclear complex means. Okay. Basically, nuclear is means all the nuclei present in the formula, and as you count the total nuclei, there are carbon and oxygen. Okay, 5 CO. So 10 atoms are there for carbon and oxygen, and 11 atoms. Okay, but that is not at all an option. Here, basically, this nuclear means any idea? How many
Mono-
metal ions are there? Yeah, pardon?
Mononuclear.
Yes, mononuclear. Why? Why? This is actually tells us about the number of metal ions. Got it? The nuclear means, okay. So just focus on the metal ions within the square bracket. Okay. So this is mononuclear complex. Is it clear or not?
Yes.
Right? Which is an example of a sigma bonded complex. This is actually on the basis of types of ligands. So this is an important question. So but very easy also. But the hurdle which we are going to face while solving it is actually the common names. An example of a sigma bonded organometallic compound. Sigma bonded organometallic compound means and some of the organometallic compounds you are very well familiar with in organic also. But these organometallic compounds are very important in inorganic in coordination. There are three names which actually are exactly same type of organometallic compound. And one organometallic compound different from the rest of the other three. Tell me.
Grignard reagent.
Yes, exactly. Grignard, very good. Grignard actually is CH3MgX. Got it. Okay. But what about this ferrocene? Very important compound. Ferrocene. And if you can figure out the ferrocene, you can figure out the cobaltocene and rhodinocene also. Got it? So, what's the structure of ferrocene? Yogita, any idea? This answer is correct. Your answer is Grignard reagent. This is the sigma bonded. Okay. Is it clear? So you have a sigma bond between the carbon and the metal. Right. So what I'm asking, what is ferrocene is? Right. So ferrocene, basically you have this kind of complex. You have Fe2 plus. So Jupiter, can you tell me what this C5H5 whole twice is? This is minus charged. Got it?
Yes, sir.
So total charge is going to be neutralized, +2 and -2, 0. So I'm not putting any charge on the bracket. Okay. So you have this. Okay. This is the cyclic ring, cyclopentadiene. Clear? And when you remove the hydrogen, you have a minus charge. Got it? So this is the C5H5 minus. So can you tell me, Jovita, one speciality of this compound?
Which compound, sir?
This one, the one which I am writing.
Ferrocene.
Yeah, no, the ferrocene has two cyclopentadiene rings, dinyl anion rings. So I'm asking what this specialty about this? Any 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 phenomena which you can associate with this? This compound is having cyclic structure, right? That you can very well clearly see it. Okay. And can you tell me how many electrons are there in the ring? Total number of electrons. Let me count it. Okay. So we have 1, 2, 3, and 4, and 6 cyclic electrons. Got it? Okay.
Yes, sir.
So they are going to move like benzene. So this is an aromatic compound. Got it? Just like the benzene. So benzene was 6 membered. This is 5 membered. Right? Is it clear? So in benzene also we see that the pi electrons are actually moving in a circular manner. That's why we put a circular circle in the center of the benzene ring. Okay, same thing you can do over here also. So you have, so why am I telling it? Because you can get this molecule in the class 11, the aromatic compounds also in organic chemistry. So you have iron 2 plus, okay? And this ring is, I'm going to make a circle, right? And put a negative charge in the center because these 6 electrons are moving in a circular manner. They are in resonance. Is it clear or not?
Yes.
So this, it has a shape like this. Okay? The iron is actually sandwiched between these two rings. Is it clear or not? So it is also known as a sandwich compound. The two rings and the metal ion is sandwiched between the two rings. Got it? And this is ferrocene, right? So this is not the sigma bonded. You can see, Jovita, clearly that this is the pi electrons of the ring getting connected to iron. In the cobaltocene, you have cobalt, exactly same structure. In the rudinosine, you have ruthenium in place of iron. Got it? Very, very important. So A, C, and D are pi bonded organometallic compounds. Pi bonded, Jovita. I hope it is clear.
Yes.
Okay, great. So do remember it because it can be asked in your organic also, GOC, and it is very well common in the coordination compounds also. Got it? So let's move to the next question. And this was asked in NEET, but in NEET they have not asked you they have not asked you basically the uh, pi bonded. They have asked you the sigma bonded. But in next time you can have the pi bonded complexes also in your examination. Got it? So let me ask you another question. So tell me the EANO. Yubita, what you mean by EAN?
Argon, sir.
This is known as effective atomic number. Okay. You know how to calculate it? If you don't know, I will explain it.
So can you explain?
Yes, I will explain it. Okay. So this is the theory related to the formation of chemical bonds, formation of coordination compounds or complexes. EAN theory or the EAN rule. As per this theory, the central metal atom or ion tries to form complex with the ligands. Why try to form complex with the ligand? Such that its total electron become equal to that of the noble gas. Are you getting my point or not? It is just like the octet rule. So in this, EAN is actually basically the effective atomic number, which tells us about the total electron. And whether the EAN rule is being followed or not, that depends upon the total number of electrons. Are they matching with the total number of electrons present in the noble gas? If they are matching, then EAN is followed. And if they are not matching, we will say that the EAN rule is not followed. Are you getting my point or not? I will give you the example. So find the EAN of iron in the two complexes. They are K4 Fe6 and K3 Fe6. And just try to figure out whether the EAN is followed or not. Got it?
Yes, sir.
So first of all, I will start with the iron. Iron is the 26th element. Okay. But in these two complexes, it is not the iron, it is the cation of the iron. So I need to figure out, in order to get the actual number of electron, I need to figure out how many what is the positive charge on the iron. Is it clear?
Yes, sir.
So what is the charge, what is the oxidation state of iron in both the complexes?
What's up?
What is the charge or the oxidation state of iron in this complex? What is the charge or the oxidation state in this complex? Is it iron +1, +2, or +3? Because you need to find the electrons. In order to find the electron, you need to know the charge. Are you getting my point? What is the charge on the iron in these complexes, both of these? So what is the charge on iron in this complex?
+1.
+1. So you can know not +1.
+2.
Yes, +2. This is ferrous, potassium ferrocyanide. This is +2. And what is the charge? So how many electrons I will be having? 26 were there on the iron. +2 means 2 electrons were removed. Got it? 26 minus 2.
Yes.
Is it clear or not?
Yes, 24.
In this case, it is +3. So how many electrons we are having? 26 minus 3 because 3 are removed because you have plus 3 charge. Okay, but there are 6 ligands. Okay, 6 cyanide ions. And they are donating 6 lone pairs. Each lone pair has 2 electrons. Are you getting my point?
Yes, sir.
And so there are 12 electrons from 6 cyanide ions given to iron. Got it? Is it clear? So plus 12 because there are 6 cyanide ions, each one is giving 2 electrons. So there are 6 cyanidoligands, 12 electrons are being given by the ligands to the metal ion. Is it clear? So how effectively, how many electrons the iron atoms are having in both the complexes? How many electrons total, including their own electron and the electron donated by the ligands? What is the total number of electrons? In the left hand complex, Yogita, how many there will be? 36, right?
Yes.
And this is going to be 35.
35.
Exactly. Yes. So which number represent the or is equal to the atomic number of the noble gas? Or I can say, or I can ask where the number of electrons of the iron are matching up with the atomic number of the noble gas. So what is the atomic number of krypton? Can you tell me? Neon was having 10 electrons, got it? Argon 18. And krypton is having 36 electrons, got it?
Yes, sir.
Okay. So where, in which complex, the total number of electrons, including the electrons of the metal ion itself and the electron donated by the ligands, are matching with the total number of electrons present in a noble gas, that is this complex. Is it clear? So I will say that this K4FeCN6 is following the EAN. Got it? And the EAN is violated. Is it clear or not?
Yes.
So in the earlier theory, it was said, earlier theory, okay, be very careful. It was said, so wherever this EN matches with the noble gas, okay, that complex is stable. And wherever it doesn't matches, that complex is unstable. Okay. But later it was found that this is not the case, right? EN can match or it may not be able to match. Okay. Is it clear? Right?
Yes.
So it may match or it may not match, but that doesn't mean that it is, if it doesn't match, doesn't mean that it is unstable. Got it? Is it clear or not?
Yes.
So let's do one more example of yeah.
Can you end the class as I have to go outside?
Yeah, okay. Not a problem. Right?
Sorry,
Or
sir.
if you just you can revise this, okay, and next class you can, right? Okay.
Thank you, sir.
Bye.